Welcome everyone to the MoldX3D webinar series. My name is Alex Baker from the MoldX3D North America office here in Farmington Hills, Michigan. The topic of today's discussion is how to reduce or optimize your cycle time using simulation. So we're going to have a little bit of an introduction to cycle time in general. Then we're going to jump into a few topics on how we can optimize our cycle time. Now, the injection molding cycle is split into generally 4 sections. We have the filling stage, we have the packing stage, we have the cooling stage, and then we have kind of everything else. So that includes the mold opening, the ejection, mold closing, and the injection unit moving forward. And this is all done kind of before the cycle. And then you have your kind of your 3 hallmark stages of the actual process of injection, which is filling, packing, and cooling. So those are the 3 stages that we're looking to optimize. Everything else is pretty much logistics and is going to be capped out by the machine that you're using. But we can optimize or open up our process window a little bit by optimizing some of the processing parameters in the filling, packing, and cooling stage, and how each of these times impacts the cycle is extremely important in how to evaluate your simulation results. All right, so I am going to do most of this on a live project, just so you guys can see my procedure and how I would go about optimizing the cycle time for any particular simulation. All of this information is up on our YouTube channel, so if you do have any questions or if you want to rehash this information, like I mentioned, you can fill out the survey to receive a recording of this webinar, or you can go onto our YouTube channel, MoldX3D North America, and this information is also present there as well. Now, when we're talking about optimizing the filling time, there's a couple of things that we can look at. The first thing is what's called U-curve theory. U-curve theory allows us to reduce the injection pressure as our injection time increases, or I should say at a low injection time or a high injection speed. We can get this buildup of pressure that's created by the material that's not able to just flow like water, right? There's going to be some sort of buildup of pressure eventually, and the left side of our curve shows that the pressure pretty much goes to infinity as our injection time approaches 0.